execution. Already in transaction management, we have seen the need of concurrent execution in transaction execution. And these are the chapter content. First, we will see the concurrent execution. Then we'll see what is a schedule. There are various kind of schedule. We will discuss about serial schedule and concurrent schedule. Then equivalent schedule. What is a equivalent schedule? There are generally two kinds of equivalence. One is a result equivalence, another one is a conflict equivalence. Those things we will discuss here. Then serializability, another new concept we will discuss here. Serializability, one is your conflict serializability. What is conflict serializability? With example we will understand. Then testing of conflict serializability. There are some shortcut method to test the conflict serializability. We will see that using your graph. Then view serializability. We will see what is view serializability and how to test a schedule is view serializable or not. And the shortcut method is a precedence graph technique, that also we will see. First we will see what is concurrent execution. Concurrent execution of transactions means executing more than one transaction at the same time. Okay. If transaction T1 is there and T2 is there, if simultaneously we will execute both of the transactions, transaction T1 and T2 simultaneously we will execute, then we call this as concurrent transaction or concurrent execution of transaction. In the serial execution, one transaction can start executing only after the completion of previous. Okay. So for T1 and T2, then if we execute T1 and T2 in serial manner, then first T1 will be executed, then T2 will be executed, or first T2 will be executed, then T1 will be executed. This is a serial execution as well as this is a serial execution. Okay. This is just serial execution. The advantage of using concurrent execution of transactions are already I have told you in previous cases. Whenever serial execution of transaction is there, the database is always in consistent state. Okay, whenever transaction T1 executes completely, then transaction T2 execute completely, then always the database will be in consistent state. There is no chance of inconsistency coming serial execution. Okay, but why we need concurrent execution? We need concurrent execution to increase the efficiency of the CPU. To increase the efficiency of the CPU or to increase the throughput of the CPU, we generally prefer concurrent execution. That means a transaction T1 or T2, any transaction, it generally consists of some IO operation and some CPU bound operations. Here read A is IO operation, it is a CPU operation, CPU bound operation, this is IO operation, this is IO operation, this is a CPU bound operation, this is IO operation. When a transaction is executed in serial manner, when one instruction is of CPU bound, then IO bound, then it will execute IO. At that moment, CPU is idle. Okay, that means the CPU efficiency decreases in case of serial execution. That's why whenever T1 transaction is executed and T1 transaction is executing first instruction, that is a IO bound instruction, that means it is requiring IO for its execution. At that moment CPU is idle. At that moment another transaction T2 can be executed where execute one instruction where that is a CPU bound instruction. That means CPU will be busy. That means in case of what process management also, the main aim of CPU efficiency, increase the CPU efficiency by engaging CPU always. Okay, similarly in this case also we need concurrent execution to improve the throughput or resource utilization of CPU and reduce to waiting time. That means ultimately concurrent execution of transaction is needed to increase the CPU efficiency. To increase the CPU efficiency, generally we need concurrent execution of transaction. The database system must control the interaction among the concurrent transactions to prevent them from destroying the consistency of the database. It does this through a variety of mechanisms called concurrent control mechanism. Whenever we will execute transactions in concurrent manner, that means some of the instructions of transaction T1 get executed, then some of the instruction of transaction T2 get executed, then again some of the instruction of T1 get executed, then some of the instruction of T2 get executed. At that moment, what happens? The database may goes into a inconsistent state. Inconsistent state. Okay. To avoid inconsistency, one mechanism is there, that is concurrency control mechanism. Okay, that using that concurrency control mechanism, we generally get consistency even if the transactions are executed in concurrent manner. That we'll see. Suppose here two transactions are there, T1 and T2, and T1 is a transaction which transfers $100 from account A to account B. Okay, and T2 is a transaction which transfers 20% of balance from account A to account B. These are the two transactions. In this example, we will take in this chapter generally. Okay, transaction T1 is a transfer of $100 from account A to account B, and transaction T2 is transfer of 20% of account balance of A from account A to account B. Okay, now we'll see what is a schedule. Concurrent execution of transaction means executing more than one transaction at the same time. Okay, that is a concurrent execution of transaction. Then what is a schedule? A schedule is a sequence that indicates the chronological order in which instruction of concurrent transactions are executed. Okay, schedule means suppose in this case transaction T1 and T2 get executed, then we can say S1 is a schedule where T1 executed first, then T2 executed. S2 is a serial schedule, S1 is a serial schedule, S2 is a serial schedule, T2 executed first, T1 executed. Otherwise, I can say chronological order in which the instruction get executed. Suppose S3 is instruction where read R1A, comma read A. Then here suppose R2A. Suppose first read instruction of A executed of transaction T1, then transaction T2 read instruction A of transaction T2 get executed. Then we can say R2A, that means transaction 2 read operation of A of transaction 2. Then we can say write of A. Then we can say W1 of A, then W2 of A. In this way, we can write. This is the chronological order in which the each instruction of various transactions get executed. That is known as schedule. Okay, we'll see later on. A schedule for a set of transaction must consist of instruction of those transactions. Yes, we must preserve the order in which the instructions appear in each individual transaction. Okay. Then what is a serial schedule? What is a serial schedule? A serial schedule is a schedule where all the instructions belonging to each transaction appear together. Okay, we'll see the example of serial schedule later on. There is no interleaving of transaction operations. A serial schedule has no concurrency and therefore it does not interleave the actions of different transactions. For n transactions, there are exactly n factorial different serial schedule possible. Suppose already we have taken one example, T1 transaction and T2 transaction. T1 consists of several instructions, T2 consists of several instructions. Okay, what is a serial schedule? If all the instructions of T1 get executed first, then all the instructions of T2 get executed first. It is a serial schedule. Okay, a schedule is known as if all the instructions of T1 get executed, after that all the instructions of T2 get executed, then that is a serial schedule. Suppose this is S1 and S2 is a serial schedule. If all the instructions of T2 get executed, then all the instructions of T1 get executed. Okay, that is your serial schedule. Now we'll see this is one example. This is the transaction T1. Transaction T1 means transfer of $100 from account A to account B, and transaction T2 is your transfer of 20% of account A from account A to account B. Okay, and this is your schedule 1. This is your S1 or schedule 1, and this is a serial schedule. Why? Because all the instructions of transaction T1 are executed first. After that, all the instructions of transaction T2 are executed. That means this is your serial schedule. And in this case, this is also a serial schedule because all the instructions of transaction T2 are executed first, then all the instructions of transaction T1 get executed. Okay, this is all about serial schedule. Now we'll see concurrent schedule. Suppose the transaction T1 and T2, same things are there. And what is a concurrent schedule? I have already explained. In concurrent schedule, operations from different concurrent transactions are interleaved. Okay. Suppose in this case, this is your transaction T1. Okay. And this is your transaction T2. Suppose in interleaved manner, we will execute this transaction T1 and T2, then that will be your concurrent schedule. Just see here. Suppose schedule 3. Suppose read A is equal to A minus 100, write A. First 3 instructions of transaction T1 get executed. Total 6 number of instructions of transaction T1 are there, but first 3 instructions are executed first. Then first 4 instructions of transaction T2 get executed. then rest three instructions of transaction T1 get executed, then rest three instructions of transaction T2 get executed. This is the concurrent execution of instruction of various transactions. This is your concurrent schedule. Okay. This is also example of schedule 4 is also example of concurrent schedule. Here first two instructions are executed of transaction T1, then five instructions of transaction T2 get executed, then the rest of the four instructions of transaction T1 get executed, then rest of the two instructions of transaction T2 get executed. Okay, and in this case also, this is also a concurrent schedule, because first three instructions transaction T1 get executed, then the first three instructions transaction T2 get executed, then the rest uh, second two instructions after fourth and fifth instructions of T1 get executed, then from fourth to seventh instructions of T2 get executed, then last instruction of T1 get executed. This is also a concurrent schedule. In case of serial schedule, if n number of transactions are there, then n factorial number of serial schedules are possible. But in case of concurrent schedule, if n number of transactions are there, then much larger than n factorial number of concurrent schedules are possible. Okay. Now we will see equivalent schedule. What is equivalent schedule? Two schedules, suppose S1 and S2 are said to be equivalent schedule if they produce the same database state. Okay, if they produce the same database state, then they are known as equivalent to each other. There are generally two kinds of equivalence. One is a result equivalent schedule and another one is a conflict equivalent schedule. What is a result equivalent schedule? Two schedules are said to be result equivalent if they produce the same final database state for some initial value of data. We will take one example and we will understand this. Suppose some initial value we will take. Okay. Well, I will discuss this in using one example. Okay, here one example is there. Suppose the following schedules are result equivalent for the initial value of x and y respectively or not. Okay, we have to check this. Suppose x is equal to 2 and y is equal to 5 here. If finally x value and y value, whatever value is produced by this schedule, the x value and y value, whatever value will be produced by this value, if both are same, x value is same and y value is same, then we can say that both of the schedule S1 and schedule S2, both S1 and S2 schedule are result equivalent. Okay, just see, just analyze. Suppose x is equal to 2, now here it will read 2, then x is equal to x plus 5, that means 2 plus 5 is equal to 7. Then write x, that means 7 will be written, x value 7 will be written in your buffer. Then read x, that means 7 will be read by transaction T2 because it is in buffer. Then x is equal to x into 3, that means x value will be 21. Then write x, that means 21 will be written to the buffer. Now read y, it will read y value as 5, then y is equal to y plus 5 means 5 plus 5 is equal to 10, then 10 will be written to the buffer. That means in buffer the x value will be your 21 and the y value will be your 10. Okay, this is your final state, this is your initial state. In this case also x is equal to 2 and y is equal to 5. If this schedule get executed, then what will be the result of x and y, we will see. First read x, it will read 2, then x is equal to x into 3, that means x value will be 6. Now write x, that means 6 will be written to the buffer. Now read x, that means from buffer x is there, that means x will be read. Then x is equal to x plus 5, 6 plus 5 is equal to 11. Write x means 11 will be written to the buffer. This is the final value of x which has written to the buffer. Then read y, y value will be 5, 5 plus 5 is equal to 10, then 10 will be written to the buffer. That means the final value of x will be your 11, final value of y will be your 10. Okay. Is the state of x and y same in both the cases? Here x value is equal to 21, here it is 11. This is not same. That means both of the schedule S1 and S2 are not a result equivalent. Both of the S1 and S2 are schedule are not result equivalent. Understood? This is all about result equivalent. Then what is conflict equivalent schedule? Two schedules are said to be conflict equivalent if all the conflicting operations in both the schedules must be executed in the same order. What is conflicting operations? Now we'll see. The conflicting operations are read write, write read, and write write. These are known as conflicting operations. Suppose read to write, write to read, and write to write operations are there. These are not allowed, or these are your conflicting operation. If a read to read operation is there, this is allowed. This will not create any conflict. This is non-conflicting operations. But all these first three are your conflicting operation. Okay, operations. If conflicting operations are present in two schedules, suppose S1 and S2, suppose conflicting operation read write is present here, write read is present here, write write is present here. In S2 also read write is present, write read is present, write write is present. Then we can say that S1 and S2 are conflict equivalent of each other. Okay. And another three conditions you have to remember here: different transaction, and this read and write should be in different transaction, and same data item. This read and write of different transaction with the same data items. That means read A and write A is present. Suppose the read A is present in TI and in TJ write A is present, then that is your conflicting. If read A is present here, write B is present here, that will not create conflict. If same data item is there, then that will create problem. And the transaction are of different. That means in TI, if read A, write A present, that will not create conflict. We cannot consider that as conflicting operation. If TI, read A is present in TI and write A is present in TJ, then that will be a conflict operation. Okay. And at least one write should be there. In read write conflict, one write is there. In write read, one write is there. In write write also two writes are there. That means at least one write should be present in the operations. Then we can say that is a conflicting operation. And whenever read read operation is there, that will not create any conflicting operation. Then what is conflict equivalent schedule? If the conflicting operations in both the schedule S1 and S2 present in the same order, that means suppose here read write conflict, write read conflict, write write conflict in the same order, read write, write read, write write conflict are present in S2, then we can say that S1 and S2 are conflict equivalent to each other. Now we'll see one example of conflict equivalent schedule. Suppose check whether this in question number 1 S1 and S2 are conflict equivalent of each other or not. If the conflict operations are present in both S1 and S2 in same order, then we can say that conflicting equivalent is there. Suppose here read X is there, here read X. It will not create any problem, but here write X is present. That means read X to write X. This is your 1. That means read X to write X, conflicting operation 1. Here write X is there, here read X is there. This is your second conflicting operation. That means write X to read X. That means this is R1X to W2X, W1X to R2X. Then is there any conflicting operation? X different data item is there. So for write X and write Y, but here X and Y are different data item. This will not conflicting operations. Okay, this much only. And in this case, we'll see from read X to here write X. Yes, this is your first conflicting operation. R1X to W2X. Okay. Then write X to read X. This is W1X to R2X. Okay. Then is there any conflicting operation? Read to write, but here X, here Y. Okay. These are the two conflicting operations present here. Here also two conflicting operations present here. 1, 2. And both of the same are in same order. Both the conflicting operation in both the schedule in same order. That means S1 and S2 are conflict equivalent to each other. That means S1 is conflict equivalent to S2. Okay. Now we'll check for second schedule. Okay, here the schedules are given in different manner. Suppose in this way if schedules are given, then you have to draw the table. Okay, then what is the schedule S1 for transaction T1, transaction T2 is there. Okay, here R1A is there, R2B, that means read B, then your W1B, that means write A, then your W2B, write B. This is your schedule 1. Then what is your schedule 2 is 2 T1 and T2. Okay, R2B, that means read B, R1A, read A. Okay, W2B, WB, write B, and write A. Okay, these are the operations. Then in this case, we have to see is there any conflicting operations present? Read A to write B? No. Your data items are different, A and B. This is not conflicting. Read A to write A here not conflicting. No conflicting operations is present in both in schedule S1. In S2, we'll see is there any conflicting operations present? Read to write, but here B is present, here A is present, here also A is present, B is present. No, here also no conflicting operation is present. That means S1 and S2 are conflict equivalent to each other because no conflicting operations is present in both S1 and S2. Okay, that means here S1 and S2 are conflicting operation in question number 1 and S2 is question number 2 also both S1 and S2 are conflict equivalent to each other. Now we'll see question number 3. Okay, suppose schedule S1, it consists of how many transactions? 1, 2, yes, 2 transactions. That means T1 and T2. Then T1, T2, what are the transactions? Read A, R1A, that means here read A. Then W1A, write A. Then here read B, write B. Read B, write B. Then here R1B. Then here read B. Okay, then similarly S2 will be here, T1 and T2, two transactions are there. Then read A, read A, write A, read A, read B, write B. Now we have to see whether conflicting operation is present in this case or not. Okay, read A, here A is present, here B is present, no problem. But in this case, just see read A, read B, no problem. Write B, write B and read B. That means T2 to T1. That means W to B to read B or 1B. This is the conflicting operation. In this case, we have to see is there any conflicting operation? All are A. In S2, read B is there. This one is your read B. Read B to write B, yes. But here R1B to W2B. Both of the conflicting operations are different. Here W to B to R1B, T2 to T1. Here T1 to T2 is present. Okay, conflicting operation is different. That means S1 and S2 are not conflict equivalent to each other. S1 and S2 are not conflict equivalent to each other. Okay. Similarly, you can find out whether S1 and S2 are conflict equivalent to each other or not in case of question number 4. Okay. Then now we'll see serializability. A concurrent schedule is serializable if it is equivalent to a serial schedule. If it is equivalent to a serial schedule, then we can say that it is a serializable. Serial schedules preserve consistency as we assume each transaction individually preserves consistency. Yes, the database system must control concurrent execution of transactions to ensure that the database state remains consistent. Since the modifications are done in the local buffer, we can ignore the operations other than read and write instructions for easier understanding of the serializability. And when we are considering serializability, no need to consider other instructions except the read and write operation because the consistency generally depend on the read and write operations of the transactions, okay, or schedules. That's why we have written all the schedules. Till now we have considered 5 number of schedules. All the schedules except the read write operations, all other operations we have removed. Here S1 is a serial schedule. This is a read A, write A, then read B, write B. And T2 transaction read A, write A, read B, write B. That means whatever transaction S1 we have considered previously, all other operations, that means transaction T1 was transferring of $100 from account A to account B. All other instruction except the read write I have removed and I have written only read write operation here. And in T2 transaction also, what was the T2 transaction? Transfer of 20% of account balance of A from account A to account B. And yes, and except all other instruction, only read write instruction I have written here. Okay. Similarly, S2 schedule was transaction T2 first, then T1 first. That means S1 and S2 are serial schedule, and S3, S4. and S5 are your concurrent schedule. And here also we have removed all instructions, all other instructions, then read and write. Okay, in S3, S4, S5. Now we'll see what is conflict serializability. Okay, a concurrent schedule is serializable if it is equivalent to a serial schedule. Conflict serializability means, we will see it here, actually which instructions are creating conflict in this case. Generally, read write, write read, and write write. If such kind of instructions are there, and though both all these three are present in both different transactions T1 and T2, read is present in one transaction, write is present in another transaction, and both read and write are executing on same what data items, then we can say that this read write is creating conflict. Then write read similarly, suppose write is present in transaction T1, read is present in transaction T2, and they are present in different transactions, as well as they are operating on same data items. That means write A and read A. That means same data items if they are operating, and they are present in different transactions, then it is a conflict operation. Then write similarly, they should be present in different transactions and same data items. Then these are the conflicting operations. Okay. A concurrent schedule is conflict serializable if it is conflict equivalent to a serial schedule. If a concurrent schedule is conflict equivalent to its one of its serial schedule, then we can say that it is conflict serializable. Just check here, take one example and check here. Suppose here S6 and S7 are two schedules. Check whether S6 is a conflict serializable schedule or not, and S7 is a conflict serializable schedule or not. For checking that, what I have did, I have taken one uh, table. That means if this S6, this schedule is conflict equivalent to one of its serial schedule, then we can say that it is a conflict serializable schedule. That means we will take one of its serial schedule, S6, one of its serial schedule we will write, and if the conflicting operation present in this schedule S6 and the conflicting operation present in its equivalent serial schedule, if both the conflicting operations are in same order, then we can say that both of the schedules are conflict equivalent to each other. And if this schedule is conflict equivalent to its one of its serial schedule, then we can say that it is a conflict serializable schedule. That's why first we have to draw one of its serial schedule. Mm, okay, suppose S8 is your serial schedule of S6. Okay, corresponding serial schedule of S6. So why? Because in transaction T1, all the instructions I have put here, and in transaction T2, whatever instructions are present, I have put in one place. Okay, now we'll see whether both of the S6 and S8 are conflict equivalent or not. If S6 and S8 are conflict equivalent, then we can say that S6 is a conflict serializable schedule. Okay, then what are the conflicting operation? First we have to find out. Here read X is present and write X is present here. Read X to write X. This is your first conflicting operation. Then here write X is present, here read X is present. Here second conflicting operation. That means first conflicting operation is R1X to W2X. Second conflicting operation is W1X to R2X. Okay. Then is there any conflicting operation? Yes. Read Y to write Y. This is your third. That means third conflicting operation is R1Y to R, sorry, W2Y. Here W1Y to W1Y to R2Y. These are the various conflicting operations. Okay. Uh, Now we'll see here the conflicting operations are in same order or not. R1X to W1X. Yes, this is 1. W1X to R2X. This is 2. R2X to R1Y to W1Y. This is your third. This is your second. This is your third. Sorry, this is your second. is a fourth. Okay, that means what are they? Suppose R1x to W2x, W1x to R2x, R1y to W2y, and W1y to R2y. Just see the order of conflicting operation in both the schedule are same or not. Yes, one R1x W2x, R1x W2x, W1x R2x, W1x R2x, R1y W2y, R1y W2y, W1y R2y, W1y R2y. Yes, that means all the conflicting operations present in schedule 6 are equivalent to schedule 8. That means we can say that S6 is a conflict serializable schedule. That means S6 is a conflict serializable schedule because it is equivalent to conflict equivalent to one of its serial schedule. Similarly, we will check for S7. Question number 1. That means this one is a S6 is a conflict serializable schedule. Now we'll check whether S7 is a conflict serializable schedule or not. To check whether S7 is a conflict serializable schedule or not, first we have to draw one of the serial schedule. If it is conflict equivalent to its serial schedule, then we can say that S7 is also a conflict serializable schedule. Then this is the corresponding what serial schedule of S7 schedule. Okay, all the instructions of T1 I have written first, then all the instructions of T2 I have written later on. Okay, now we'll see what are the conflicting operation present here. Here, read x to write x. Okay, that means first one is your R1x to W2x. Then second one is your W1x to R2x, W1x to R2x. Then what is your third one? Read y to write y. Okay. Okay, here both are same actually. Okay, that means this will also a conflict serializable schedule because here S6 and S7 are both are same. Okay, that's why it is a conflict serializable schedule. But what is conflict serializable schedule? Conflict serializable schedule is if any schedule which is conflict equivalent to any of its serial schedule, then we can say that that schedule is a conflict serializable schedule. Okay, understood. Now we see. We have seen how to check the conflict serializable schedule, but there is one but a shortcut method to check the conflict serializable schedule, that is known as precedence graph. Using precedence graph, we can say whether a concurrent schedule is a conflict serializable schedule or not. We have to draw one precedence graph. If that graph contains cycle, if the graph contains no cycle, then the schedule is your conflict serializable. If the graph contains cycle, then that schedule is not a conflict serializable schedule. Understood? If cycle is present, if no cycle is present, then conflict serializable. A schedule is conflict serializable. If no cycle is present, then that is a non-conflict serializable schedule. Okay. Then how this precedence graph we have to draw? Construct a directed graph called a precedence graph from S. From that schedule we have to draw this precedence graph. This graph consists of a pair of vertices and edges. Okay, where vertices is the set of vertices and is the set of edges. The set of vertices consists of all the transactions participating in the schedule. Suppose S is a schedule and T1, T2, T3 are three transactions. Then in that graph, T1 will be a vertices, T2 will be a vertices, and T3 will be a vertices. Okay, that means all the transaction will be 1 vertices. The set of edges consists of all edges Ti to Tj for which one of these condition holds. That means if write Q or write read operation exists in between two transactions on same data items, then we can say that but different transaction, same data item, different transaction, write read or read write or write write, then draw a line from that. Suppose the write read is present W1 to R1, W1A to R2A, then 1 to 2 we have to draw the what arrow in this way. Okay, in this way we have to create the precedence graph. At last we have to see if one cycle is present. Suppose T1 to T2 one arrow is there, T2 to T1 one arrow is there. If cycle is present, then we can say that the schedule S is not a conflict serializable schedule. If no cycle is present, then we can say that it is a conflict serializable schedule. Okay. Now we will check for schedule S1. Now we'll check. For schedule S1, we'll check whether it is a conflict serializable schedule or not using precedence graph. Here two transactions are there, T1 and T2. That's why two vertices we have to draw. Then we have to see, is there any conflicting operations, read A to write A. That means yes, that is a conflicting operations. That means T1 to T2 I have to draw a line. Is there any line we have to draw from T2 to T1? All are here, write A to read A, read B to write B, write B to read A. All are from T1 to T2. That's why here cycle is not present. As cycle is not present, we can say S1 is a conflict serializable schedule. Okay. Now we'll check for S2. Now again, two transactions are there. So two vertices we have to draw. Then we have to see read A to write A. Here it is a conflicting operation. That means we have to draw like this. Write A to read A. Yes, this is a conflicting T2 to T1. Read B to write B. That means T2 to T1. Write B to read B. T2 to T1. No cycle is present. That's why S2 is a conflict serializable schedule. Now we'll check for S3. Here also two transactions are there. That's why two vertices we have to draw, T1 and T2. Now we'll check for conflicting operation. Read A to write A, write A to read A. All are from T1 to T2. Now check for here. Read B to write B, write B to read B. All are from T1 to T2. No cycle is present. That means S3 is a conflict serializable schedule. Okay. Now check for S4 whether it is a conflict serializable schedule or not. S4 two transactions are there. That's why T1 and T2. Two what vertices we have to draw. Read A to or write A. Conflict from T1 to T2 is present. Then read A to write A here. T2 to T1. The cycle is present, no need to check further. That means S4 is a non-conflict serializable schedule. It is not a conflict serial. S4 is not a conflict serializable schedule. Okay. Now we'll check for S5. Two transactions, T1 and T2. Then read A, write A. Here operation is there, conflict operation. That means T1 to T2. Then here read B, write B. Okay, here T2 to T1. Okay, cycle is present. That means S5 is not a conflict serializable schedule. In this way, you can check using precedence graph. You can check the conflict serializability schedule, whether a schedule is conflict serializable schedule or not. Okay. Now we'll see. Okay, and this is all about your schedule S1. S1 cycle is not present, schedule S1. That means it is a conflict serializable schedule. Schedule S2 cycle is not present, conflict serializable schedule. Schedule 3 cycle is not a conflict serializable schedule. Schedule 4 cycle is present, not a conflict serializable schedule. Schedule 5 cycle is present, not a conflict serializable schedule. Understood? Now we'll see view serializability. We have completed conflict serializability. Now we'll see view serializability. A schedule S is view serializable. Okay. A schedule S is view serializable if it is view equivalent to a serial schedule. In case of conflict serializable, the schedule, if the schedule is conflict equivalent to a serial schedule, then that is conflict serializable. In case of view serializable, if it is a view equivalent to one of its serial schedule, then it is known as view serializable. What is view equivalence? Two schedules are view equivalence if and only if for every read operation, the source should be same in both the schedules. Assume an initial transaction T0 which writes every data item and a final transaction TF which reads every data item. Suppose two schedules S1 and S2 are there. Here T0 and T1 or T1 and T2. Two transactions are there. In this case also T1, T2, two transactions are there. Okay, and here what are the various operations? R1x, then here suppose W2x, then here suppose W1x, and another transaction T3 here W3x. Suppose another transaction R1x, W1x, W2x, and T3 one transaction is there W3x. Are these schedules S1 and S2 are view equivalent to each other? Then what are the various read operations? And here we have to assume two operations, transaction T0 and TF. T0 writes every data items. Here what is the data item? X is written by T0 and it will be read by T1. And S2, in S2 also, T0 is a transaction and TF is a transaction. It writes all the data item, it reads all the data item. Okay, then the sources of a read operation. In this case, what are the sources of read operation? Here this is the sources of read operation. It reads from T0. In this case also R1x it reads from it reads from T0. In this case also it reads from T0. In this case RF, it also reads all the data item from T3. Here also TF reads from T3. T3 writes the data item that is read by TF. That means in both the schedule S1 and S2, the sources of read operation is same. That's why S1 and S2 are view equivalent to each other. Then what is view serializable schedule? A schedule is said to be view serializable schedule if and only if it is view equivalent to any of its serial schedule. Okay, if it is view equivalent to any of its serial schedule, then that is known as view serializable schedule. What is view equivalent? All of you understood? View equivalent means sources of a read operation should be same. And if for any serial schedule, for this schedule, for its any serial schedule, if it is view equivalent with that schedule, then we can say that it is a view serializable schedule. A schedule, okay, now we'll see that. Suppose here transaction, here schedule S is 7 is there and schedule 8 is there. It is a view serializable schedule or not. Another way of checking view serializability is we can take one serial schedule and we can check whether both of the schedule are views equivalent or not. And another thing is that using polygraph, taking one graph that is known as polygraph. Okay, using polygraph also we can check whether the schedule is view serializable or not. How to draw the polygraph? First, you have to take one operation, transaction T0, another transaction TF. In this case also T0 is another transaction, TF is another transaction. Okay, what you have to do, all the transaction you have to write as a node. For schedule 7 I am writing T0, then T1, then T2, then T3, then TF. Okay, T0 writes all the data items and that is first read by T1, and T3 writes all the data item that is read by TF. Okay, then from T1 writes the item, from T1 T3 is writing. That means after T1 T3 is writing, that means here we have to draw a line. Then from T1 T2 is writing. Okay, that means it is reading from here. Then from T2 T1 is there. Okay, it is reading from there. In polygraph, if cycle is present, then in polygraph, if cycle is present, then that is uh, in polygraph, um, cycle is present, that is not a view serializable schedule. It is, that means this schedule number 7 is not a view serializable schedule. It is not a view serializable schedule. Now check for schedule 8. Schedule 8, we will draw the polygraph for T0, then your T1, then T2, then T3, and here TF. T3 writes the data item, it is reading. T0 is writing, it is reading. Okay. Now T1 to T2 transaction is there. Then T2 to T3 transaction will be there. That means no cycle is present in this case. And T1 to T3 directly. T1 to T3 write operation reading. T3 is ready. Right. T1 to T3 operation is there. Okay. No cycle is present in this case. That means it is schedule number 8 is a view serializable schedule. Okay. And another thing we have to see here, a schedule is view serializable if it is view equivalent to a serial schedule. We have already seen that. Then this schedule is a view serializable. This schedule is not conflict serializable. Okay. Whenever a schedule is a conflict, another thing you have to remember, whenever a schedule is a conflict serializable schedule, it is automatically it will be a view serializable schedule. Okay. If a schedule is not a conflict serializable schedule, then we have to check whether any blind write is present or not. What is blind write? This is a blind write. This is a blind write. Write, if for a write, before that read operation is not present. Here read operation is not present. Here also read operation is not present. This is known as blind write. Okay, if conflict serializable, a schedule is not conflict serializable, and at least one blind write is present. At least one, here two blind writes are present. At least one blind write is present. Then check for polygraph. If in this polygraph a cycle is present, then this is not in view serializable schedule. If in this polygraph cycle is not present, this is a view serializable schedule. Okay. But if a schedule is conflict serializable schedule, if a schedule is your conflict serializable schedule, then automatically it is a view serializable schedule. Okay, whenever a schedule is conflict serializable, it is a view serializable schedule. Suppose one schedule is not a conflict serializable schedule, as well as no blind write is present. No blind such kind of writes are not present, then directly you can say it is not a view serializable schedule. And this thing can be summarized in this way. Suppose one schedule S is given. First, you have to check for conflict serializability using precedence graph. In the precedence graph, suppose you have drawn a precedence graph. In the precedence graph, if cycle is not present, that means no cycle is present, then that schedule is a conflict serializable as well as view serializable schedule. If cycle is present, then you have to check whether any blind write is present or not. Right before, suppose one write is present, before that no read operation is there, then that is known as blind write. If no blind write is present and cycle is present, that means it is not a conflict serializable schedule as well as no blind write is present, then that is not a view serializable schedule. If a blind write is present, again you have to check for view serializability condition. That is your polygraph. Okay, you have to draw the polygraph. In the polygraph, if cycle is present, it is not a view serializable schedule. In the polygraph, if no cycle is present, that is a view serializable schedule. Then how to draw the polygraph? To draw the polygraph, suppose one schedule is given, various transactions T1, T2, T3 are given. Okay. Then what you have to do? First, you have to take another transaction T0 and another transaction TF. Think that T0 writes all the data items, TF reads all the data items. Then for all the transactions, draw one node T0, T1, T2, T3, then your TF. Okay, then it reads, then which transaction is reading the data item first, that you have to see. Then T0 is writing, T2 is supposed reading. Then T0 to T2 you have to draw a line. Okay. Similarly, suppose which final write is done by which transaction. Suppose T1. Then from T1 to TF, you have to draw a line in this way. Then again, you have to see. Suppose T1 has executed, T2 has executed first, T1 has executed last. That means then T3 to T2 some operation is there. Then T2 to T3 will be there, and T3 to T2 will be there. Okay. In this way, you have to draw the lines. Okay, and if cycle is present, then not a view serializable schedule. If no cycle is present, not a view serializable schedule. Okay, in this way you have to check. And this is all about your view serializability. And another thing I want to tell you here, a schedule that is not conflict serializable but view serializable must always contain at least one blind write operation. This you have to remember. And if a schedule does not contain any blind write operation, both conflict serializable and view serializable conditions are same. Okay. That means if blind write operation is not present, if a schedule is conflict serializable, then it is a view serializable. If it is not conflict serializable, then also it is not view serializable. Okay, that thing we have. Thank you.